All right, our last FRQ review video, number 5, 2019. We're wrapping up our Type 7 area and volume review. Let's go ahead and get started here. It says, let R be the region enclosed by the graph of G and H, the y-axis and the vertical line x equals 2, as shown in the figure to the right. Find the area of R. Well, first thing we need to do is identify which function is which here. This is not a calculator problem, so we need to be able to recognize this ourselves. The first thing I notice is that h of x is a parabola and it opens down. So this has to be h of x. Which implies that this is going to be g of x, and that makes sense because this is a cosine function and cosine is kind of curvy like that. So we would say the top thing is h of x and the bottom thing is g of x. And we are looking for the area of this region. So remember, the area of a region bounded by curves is the integral of the upper curve minus the lower curve. So it would be the integral of h of x minus g of x from 0 to 2. The problem is this is a non-calculator problem, which means I'm going to have to go through and do the work myself. So I'm going to have to write all of this out. I don't want to use h and g for my work. So I'm going to say 6 minus 2 times x minus 1 squared minus negative 2 plus 3 cosine of pi over 2x dx. Now that's a doozy. We're going to have to evaluate that. So let's go ahead and simplify that a little bit. By distributing this negative here, we're going to get plus 2, and I can add that to the 6 out front. So I get 8 minus all of that. Now some of you might say, well, why don't we simplify the x minus 1 squared and distribute all of that? And you can do that, but because there's no exponent inside the parentheses and there's no constant multiple inside the parentheses, this antiderivative of that is actually going to be pretty easy. So the antiderivative of 8 is 8x. Now the antiderivative of negative 2 times x minus 1 squared, well, I notice that negative 2 is a constant. X minus 1 squared, so I'm going to add 1 to the squared, so I'll get x minus 3, I'll get x minus 1 cubed, x minus 1 to the third, and then I have to divide my coefficient by my new exponent to get the correct coefficient. Again, check your work, take the derivative, make sure it matches your integrand expression. So 3 times 2/3 is 2, times x minus 1 to the second, and then times the derivative of the inside, which in this case is just 1, so we're good there. Then this guy, again, it's a doozy. Okay, so what is the antiderivative of cosine? Well, what function gives us the derivative being cosine? Well, that'd be sine. So here's my constant out front. It's going to be, I'll just put the negative there to represent that. Okay, the antiderivative of cosine is sine. And so you say sine of pi over 2x, and then the coefficient is going to be 3 divided by the inside. So 3 divided by pi, 3 divided by pi over 2, and that simplifies to 6 over pi. So basically you're going to take the reciprocal of this and multiply it by 3. Again, take the derivative to make sure it makes sense. The derivative of sine of pi over 2x is cosine of pi over 2x. And then times pi over 2. So when I multiply 6 over pi times pi over 2, I end up with the 3, and the negative is still out there. So then we're going to evaluate that from 0 to 2, which means we're going to plug in 2 to x, and we're going to plug in 0 to x, and then subtract. And again, being very careful here, because oftentimes we think when we plug in 0, the whole thing's going to cancel out, and that's not true in this part right here, so we got to be careful with that. Anyways, 8 times 2 is 16. 2 minus 1 cubed, that's going to be 1, and then times negative 2/3 is negative 2/3. And then sine of pi is just 0. So that's all going to cancel out here. 8 times 0 is 0. And then negative 1 cubed is negative 1 times negative 2/3 is plus 2/3. And then the sine of 0 is just 0. And so we ultimately end up with 16 minus 2/3 minus 2/3. Going to get a common denominator there, and then combine like terms, so you got 44 over 3 is your final answer. Again, once you get to this line right here, stop. Don't simplify any further, just leave it there. You do not need to simplify once you have numeric values everywhere. You go, well, sine of pi, that's not good enough. That's not arithmetic. It's okay. It's a numeric value, and they will accept this as your final answer. All right, point values. You're going to get 1 point for having the correct integrand. So 1 point for this guy here. You're going to get 1 point for having the correct antiderivative for the cosine function. So if you had the correct antiderivative for this piece only, so this part right here, if that is correct, you get that point. And then you get 1 point for having the other antiderivatives correct. So that's kind of nice because they realized that this was a tough one. So the antiderivative of this whole thing, if you got here, that would be that 1 point. And then you're going to get 1 point for your final answer. Again, you do not need to simplify all the way. You can leave it like this right here for that answer point. For part B, it says region R is the base of a solid. For the solid, at each x, the cross section is perpendicular to the x-axis, has an area of 1 over x plus 3. Find the volume of the solid. Well, first thing we know is that we have perpendicular cross sections to the x-axis, so that represents one cross section. Now, normally it tells us that we have some sort of shape that we're finding the volume of. Here it doesn't say that we have like cross sections that are squares or triangles or semicircles. It just gives us the equation for the area, which is kind of nice. It actually makes it easier even though we may not realize it. So remember, when we're talking about volume of cross-sectional shapes, it's always equal to the integral of the area in respect to what you're perpendicular to. Because we're perpendicular to the x-axis here, it's going to be a of x dx, and then our limits are going to be x values, so from 0 to 2. And then because it already gave me my area function, I can just plug that right in here. And so I get the integral from 0 to 2 of 1 over x plus 3 dx. Because the denominator has an exponent of only 1, the antiderivative is going to be the natural log of the absolute value of x plus 3, evaluated from 0 to 2. We're going to plug in 2, and we're going to plug in 0. So when I plug in 2 here, I get the natural log of 2 plus 3, which is the natural log of 5. And then plug in 0, I get the natural log of 3, and that's my final answer. So you're going to get 1 point for having your correct integral, so 1 point for this statement right here, with the limits and everything else correct, and then 1 point for your final answer. All right, for part C, it says write, but do not evaluate an integral expression that gives the volume of the solid when R is rotated about the horizontal line y equals 6. Well, let me go ahead and draw the line y equals 6. We can see as we revolve this solid around that line, we're going to get a washer method because we have holes here, we have gaps in between the axis and the curve. And you can visualize it this way too. There is a hole here in a sense, it's just that that hole is 0. So from here, we recognize that this is a washer. So remember, the washer method says the volume is equal to pi times the integral of r squared minus r squared. We have to figure out our big R. Our big radius is the distance from the axis to the furthest curve. Notice the curves are below here. So that is our big R. And then our little r is the distance from the axis to our closest curve. So little r is that. So we need our equations for our r. So big R is going to be 6 minus g of x, because remember, it's always the curve minus the axis or the axis minus the curve. In this case, it's the axis minus the curve because the axis is above. So it's 6 minus g of x, and our little r is going to be 6 minus f of x. And we can just plug those values into our integrand. And so we get 6 minus g of x squared, and then minus 6 minus f of x squared dx. Now I do not have to plug in this expression into g of x and this expression into h of x, or into f. Where did I get f from? I got that wrong. That shouldn't say f of x. That should say, let me fix this real fast. That should say h of x. I don't know where I got f from. Anyways. There we go. So that's fixed, and I guess up here, that is incorrect too. That should say h of x. I guess I just used the wrong letter in this problem. But anyways, there we have our volume expression. Going back to what I was saying, you don't have to plug in the equation for G and the equation for H because it's not asking you to actually solve it. It says write but do not evaluate. And so since they define G and H in there, we're good with that, and that is our final answer. As far as points go on this, you're going to get 1 point for the correct limits and the constant. So having the pi there and having the integral from 0 to 2, that's 1 point. You're going to get 1 point for the washer method. So if they can see that you did something squared minus something squared, you're going to get 1 point. And then you're going to get a second point as long as your integrand is completely correct. So 1 point for showing the washer method, r squared minus r squared, and then 1 point for having the completely correct integrand. And that is it on part C. That wraps up the review of type 7 area and volume problems. Go ahead and grade yourself and input your scores for the last 2 problems into Socrative. We are now done reviewing for the AP exam in regards to free response questions. So hopefully you have a good understanding of all 7 types and how they're graded and what they're looking for within each type and how to do each type of problem. Again, all of them are represented differently. You can get applications within different representations, so it's not guaranteed that you're going to get one type over another. They can be mixed in, but I think we've done enough examples that you can see how that plays out. So anyways, I hope that you found this beneficial. I will talk to you sometime in the future, hopefully when we get back to school or some other video or something, but I will see you soon.